Okay, this is just a part of the lesson 1-1 about finding the domain of a function, and I wanted to point this out because I've had some questions come up about it. When you're looking for the domain, it's going to be the largest set of real numbers for where the function is defined, basically. So you're really having to worry about excluding anything from the domain that can cause a division by 0 or result in an even root of a negative number. Okay, so those are the things we're looking at. So when we're looking at finding the domain, and they could just list ordered pairs. If you just have ordered pairs listed, then the domain is just all your x's. So that would be 8, -2, 1. We already have 8 and 2. You don't have to list that 8 twice. It doesn't need to be in order, any particular order. I like to just do the order that's there. The range is your y values. So let's see, that would be the set -3, 4, 8, 6, and 7. On part B, all of these would be your domain. Okay, that's all our x's, so that would be -5, 0, 2, and 4. The range is your y's, which in this case is the set -3, -2, and 1. Okay, so on the next one here, part C, we're given a graph. Now, when you're looking at domain, you're looking at your x values. So I'm looking basically left and right. So notice on the left, it has an arrow on the end, so it goes on forever. Notice on the right, it has an arrow on the end, goes on forever. So that means our domain is all real numbers, which in interval notation would be -infinity to +infinity. Sometimes you see it with a capital R with that extra little line. That is the symbol for all real numbers. The range is your y value. So here we're looking at the y's, so top and bottom. So notice that this is unbounded on the bottom. It doesn't stop, it goes on forever, but it is bounded on the top, okay, right there. So that means there's a top y. Top y is 2. So we're going from -infinity up to 2, and it does include 2. So I'm wanting you to notice that this is a continuous function because there's no holes, there's no gaps, there's nothing that's, skipped. All right, so part D, notice this is different. It's not a continuous function. It is a discrete function because it's just the dots, okay? It's not even a function, actually. This is not a function because some of these x's have 2 different y values. It doesn't pass the vertical line test. So our domain on this one, let's see, is just the x's, so that would be -3, -2, and 1. The range would be your y's, and that would be -1, 0, -2, 1, and -3. And I didn't put in any particular order. I kind of went left to right here and looked at what the y values were for each one of those. Now this is the part that I really want to pay attention to because they tell us here to use a graphing calculator after we figure it out just to verify. But I took the little graphs off because I want you to be able to figure it out without the graphing calculator. So for instance, when you're looking for domain, you are looking for any restrictions. So let's isolate our y here. We would subtract the x squared and then divide by -1 and then take the square root, and remember when you take the square root you got plus minus. So this means it's not a function because there are 2 y values for every single x value. So when we look at the domain, remember if you have a square root, and this is any even numbered root, what's under the radical has to be greater than or equal to 0. So we're going to say x squared minus 9 greater than or equal to 0. So this would be x minus 3, x plus 3. Well, maybe it'd be better to show you this way. This would be x squared is greater than or equal to 9. So since it's a greater than, it's an or problem. Greater than is an or, greater. So this would be x is greater than or equal to 3, or x is less than or equal to negative 3. You always reverse the inequality on the negative part. So that means in interval notation we're going from negative infinity to negative 3. It's a bracket because it includes it, and then we're going from 3 to infinity. Now if you graph it, that graph looks something like this. This is a hyperbola. You're going to learn more about that later on in this year. We're going to do some conics, but that's what it looks like. So notice it's got values in both directions, but it skips the middle. Okay, there's nothing in the middle. So obviously this is 3 and negative 3 in the middle, that little gap where there's no graph at all. Okay, so let's look at the next one. Okay, so this one would be y equal to x squared plus 4x. Well, I know x squared, this is quadratic. It's going to open up like this, right? Quadratic, a is positive, it's going to open up. Doesn't really matter where on the graph right now, because when I'm looking at the domain, well, this one is a function. There's only one y for every single x. The domain is going to be all real numbers. So from negative infinity to positive infinity, there is no end right there. Now part C. Okay, so this is a rational function. It looks really, really weird. You don't really need to know what it looks like to be able to answer the question of finding domain. So remember, we know that the denominator can equal 0. So I have x squared minus 4 can't be 0. So x squared can't be 4, so x can't be 2 or negative 2. Remember, there's 2 of them. Or you could factor that and do x plus 2x minus 2 if you prefer to see it that way. But that means the domain is all real numbers except for 2 and negative 2. So that means in interval notation, we're going from negative infinity to negative 2, and then negative 2 to 2, and then from 2 to infinity, like that. So when you graph it, there is a dotted line or an asymptote at negative 2 and 2. Okay, we're really not worried about the rest of it right now. You just need to know that there are asymptotes right there, vertical asymptotes. And then on part D, this one, because it's got a square root again, we want to make sure that what's under the radical is greater than or equal to 0. So I have negative 4x is greater than or equal to negative 3. So if I divide by negative 4, remember you got to reverse the inequality when you divide by negative. So x is less than or equal to 3/4. So this means we're going from negative infinity all the way to 3/4. And it's a bracket because it includes it. And so it's something that square root looks something like that. It's flipped the other direction because x has a negative by it. Yes, it is a function. So you need to be able to figure out the domain of these things without looking at the picture, because not all the time are you going to have a graphing calculator with you. There are portions of the test that will be with a graphing calculator and part that will not be with a calculator.